Welcome back, everyone. So, before we start talking about chemistry, before we start actually talking about atoms and molecules and ions and chemical equations, before we do any of that, we need to say something about the topic of measurements and how to solve problems regarding measurements. The fact of the matter is that chemistry is a quantitative subject, meaning that we use lots of numbers and mathematical equations to explain the properties of matter and how they react. Now, the fact that we use math in this class should not scare you because I'm going to talk you through a lot of the problems that you will be doing, and you will also have your scientific calculator that you can use, or that you should use for quizzes and exams. Now, in the syllabus, I mention the kinds of calculators of scientific calculators that are useful for this class. If you do not have a scientific calculator yet, please, please, please get one. It will be your best friend in this class, and you will certainly need it for this chapter and subsequent chapters in the course. So my first call to you is to get yourself a proper scientific calculator as described in the syllabus. My second request of you is to know how to use it. Now, in this chapter, we're going to talk through some of the buttons on a scientific calculator, and I've tried to include the most common calculators that are out there from Texas Instruments and Casio, but I can't address all forms of calculators. So it's really important that the calculator that you decide to purchase, as per the syllabus, you keep the manual so you can reference it if you have any questions on how to use it. Okay? So the calculator is going to be your friend in this course, particularly this chapter and in subsequent chapters. Know how to use it. And we will talk through many problems in this chapter to test your skills on how to use the calculator. Before we start doing problems, let's define a little bit about what this term measurements means. And I'm sure my son, who is now much taller and a bit older, would be horrified that I am still using this picture, but I think it's a good representation of the points about measurements that I want to make. First, I'm sure you all know that a measurement is something that determines a quantity, like height, or distance, or mass, volume, length. So measurements have a number associated with them. That's the first part of a measurement. The second part is that they also have a unit that's associated with them. And this unit, I would argue, is just as important for the measurement as is the actual physical number, because the unit tells the scientist or the doctor or the nurse what exactly is being measured. So, for example, meter, there's a symbol for meter is M. Meter is a unit of measure of length or distance. And that unit can be very important. So here is my son at the U.S. Mint in D.C. Many, many years ago, almost 10. According to this picture, if I was to tell you that my son was approximately 1,491,200 tall, you would probably shake your head, scratch your head, say, "What are you talking about, Mrs. Lapola? No one is that tall. That doesn't make any sense." But if I was to tell you that he was 1,491,200 tall in $100 bill notes, stacked from the bottom to the top. If he was that tall in $100 bill notes, then that would hopefully make some more sense to you as to the scale that was being used to measure something. And you only knew that if I told you the scale or the unit that was associated with that height measurement. So, measurements have a number and a unit associated with them. I have some representative measurements here. The number and the unit are both important when recording a measurement or dealing with a measurement in a calculation. So now you know the two parts of a measurement, the number and the unit. When we talk about a measurement, when we talk about measurements, we use these terms accuracy and precision. And admittedly, I tend to use those as synonyms, but they really do speak to two different properties or two different facets of a measurement. Something that is accurate means that it is very close, that measurement is very close to the true known value of that substance. So for example, let's say I'm a pharmacist or I work in a pharmacy and I've ordered a bunch of empty medicine bottles. Let's say according to the manufacturer, that empty medicine bottle and lid, the mass of that empty medicine bottle lid is 9.0 grams. That's according to the manufacturer. So that would be the true value of that medicine bottle, 9.0 grams. So let's say I take that medicine bottle and then I have two different scales in the pharmacy. I weigh that medicine bottle with one scale and I get 8.79 grams. I go to a second different scale and that mass for the same bottle, for the same empty bottle and lid, is 8.9 grams. Which measurement is the most accurate or the closest to the true value? Well, it would be this measurement, 8.9. That is closer to 9.0 than 8.7. So we would say that that measurement associated with scale 2 is the most accurate measurement. Accuracy is different than precision. Precision speaks to how reproducible a measurement is, or how many significant figures or how many digits, how many numbers is associated with that measurement. Now we're going to define this term significant figures later in the chapter. But for right now, you should know that something that is precise has more numbers associated with it. So for example, if I was comparing these two measurements right here, 3.1244 and 3.12, the 3.1244 would be more precise. It has more digits associated with that number. I know this number to the 10,000th decimal place. If I was to go back to my example from scale 1 and scale 2, we already said that scale 2 is more accurate, but which number is more precise? Well, I see that scale 1 gives me a mass to the 100th decimal place, so I've got 3 digits here. I only have 2 here. So while scale 2 would be more accurate, the scale 1 would be more precise because it has more digits associated with that number. So that's an example with a medicine bottle. I can also think about accuracy and precision with regards to a target. This individual was not very accurate, did not get the target, the middle bullseye at all, but very precise. Was able to repeat those darts, those measurements of where to throw those darts, very often. This person was very accurate, got the target, and very precise, very repeatable in their darts. This person probably had a little too much to drink. Neither accurate nor precise. Not on the bullseye, so not accurate, and the darts are all over the place, so not precise. So you should make sure you know the difference between accuracy and precision and be able to identify if a measurement is accurate or precise.